Welcome everyone to a virtual technical meeting related to transit and rail and data science. You guys have noticed we've done a lot of in-person meetings, so step it back a bit for this one here, just to give a nice webinar style and get a different topic over here with two different presentations today. For those of you who don't know me, my name is Alvaro Calle. I'm currently serving as the DC area director here, and I'll also be having help with Vinay over here from our ITE organization. And yeah, without further ado, I'll stop sharing my screen here and I'll pass it over to Vinay.
Thanks, Alvaro, and hi everyone. A pleasant good afternoon wherever you may be. Today we have two presentations, and our first presentation on transit, rail, and data science is led by Marc Szarkowski of Foursquare ITP. And Marc is a transportation planner and visualization specialist in Foursquare ITP's Philadelphia office. Foursquare ITP advances innovative, practical, and equitable transportation planning solutions to meet a broad array of mobility needs. Marc directs Foursquare's ITP's design and visualization team, which has a specific mission and passion for translating complex transportation projects into easy to understand visuals that garner public and stakeholder attention. For projects involving urban streetscape design, the team specializes in 3D models and clearly communicate the design and construction of various project elements. Marc's design and visualization projects at Foursquare ITP have included work in places as diverse as Charlotte, Cincinnati, Jacksonville, Albany, Atlanta, Lancaster, Pennsylvania, Washington, D.C., and New York City. And without further ado, Marc will be presenting his presentation, which is titled, Let the Pictures Do the Talking, using comparative illustrations to communicate the MTA Interborough Express feasibility study. Marc?
Thanks, Vinay, for the introduction. I'm hoping that PowerPoint is loading here. Okie doke. I'm using the virtual method because that allows me to see the slides and everyone's faces at the same time in case questions come in. So, okie doke, let's dive right into it. So today's presentation, I'll be talking about the Interborough Express feasibility study, which Foursquare ITP, AECOM, and MTA's Creative Services Department collaborated on. And just as a quick heads up that this presentation will discuss more of the 3D modeling and the visualizations of the project, more so than like the technical, the infrastructural components. I won't be focusing too much on the technical aspects of all the different stations and guideways per se. So the challenge that we pretty much faced is that we had a lot of, we'll see this on a second slide in just a second, but we had a lot of different station and guideway iterations to communicate. And the traditional method of layering these on boards, which everyone's familiar with pre-COVID, the pre-COVID era, where you kind of array things on boards, you stand by the boards and you communicate the different iterations and try to piece together the story and the difference between the different concepts, so the audience could actually understand what the difference is and how the differences affected them. And we realized that the post-COVID shift, everything shifting virtually, that there's a lot more that we could take advantage of by simple screen sharing and very simple animation. So even if the firm may not have advanced capabilities or lots of staff in animation, there's a lot that can simply be done via layered images, screen sharing, and PowerPoints. So as I said, we won't be talking too much about the techno aspects of IBX, but I did want to provide a very quick overview of the project. So it's currently a freight corridor. The Bay Ridge branch and the Fremont secondary runs through Brooklyn and Queens. It'd connect up to 17 subway lines, the Long Island Railroad, and it'd run every 5 minutes. Because the area is so dense, Brooklyn and Queens, some of the densest boroughs in the country, the population served might be close to 1 million and 250,000 jobs. So when we started the project, we considered 3 modes: BRT, LRT, and conventional rail, commuter rail. Conventional rail is a preferred terminology. And then there'd also be 3 operating conditions: below grade, at grade, and above grade. So, 3 modes considered times 3 different operating conditions is theoretically as many as 9 different sort of combinations of concepts for stations and guideways that would have to be shown. So you can imagine the complexity of showing, boards with 9 different concepts or configurations. So how could we avoid all that sort of static comparison? So as I mentioned, we started out just by creating a lot of renderings of the different stations and guideways, comparing them next to each other. And we arrayed those. It's very common, before the COVID era. And it can be difficult for the public to take a narrative away from this because the eye is constantly forced to move from one image to another image. And sometimes, this approach is still self-evidently necessary on printed materials, but with so much shifting to screen sharing into virtual presentations, we realized we could take the first step in beginning to collapse the images. So what we did, well, I'll have a close-up in a second, is we took our stills and I made sure when I rendered the different stations and guideways to render them from the same vantage point for each modal and guideway configuration. So then when these are collapsed on top of each other, a simple PowerPoint fade from slide to slide exported as a GIF or as a very brief video forces the eye, because the images are taken from the same vantage points, it forces the eye to actually see the comparisons in a way so that the eye's not moving from image to image, but is actually beginning to see how all the different modes differ from each other. Like, wow, BRT actually comes a lot closer to my building, for example, than commuter rail, which would be down in the cut would. So that sort of comparison is almost forced. Here's a close-up of that same GIF. Whereas it's not always readily apparent when the images are just stills that are sitting next to each other. And again, this doesn't require, dedicated animation staff or software. It's just a matter of generating stills, and those can even be screenshots, layering them in PowerPoint, doing a simple fade, exporting as a GIF, and boom, you have your animation there. It's just a close-up of the different vantage point, showing the difference between BRT, LRT, and conventional rail. So the next step we took after this is we realized that in the past, we didn't really do a lot of model driving, even if we had access to a conference room with the 3D modeling software and a computer where you could actually show the model in front of different stakeholders to get their input. But Teams changes all of that. Suddenly, the person doing the 3D modeling can hop right on the call with the different stakeholders. And this example is internal stakeholders within the MTA. And we just found how this so quickly changes the level of feedback and the value, the value and the content in the feedback when we screen share the model live. And this doesn't even require preparing or recording any fly-throughs. Like that can be done, but simply just hopping on and walking through the model is helpful, because previously we would share screenshot excerpts, via email. And sometimes you'd get valuable comments, but sometimes you'd still get comments later on in the process. So, oh, I didn't realize this. Can you go back and change that? And when you're further along in the project, changing the 3D model can get difficult. But at this point, we get comments, when we're screen sharing the model, like, oh, wait, go back to that ADA ramp on the side of the head house there. That doesn't look right. Or is that really how it is? We'd get comments like that are that come up at the spur of the moment because the person is experiencing the concept in 3D, and things that wouldn't typically come up when they would just review static screenshots, attached to an email or something like that. It's just a close-up of that model. I did obviously screen record the walkthrough for this presentation, but this is an example of a live drive session we had with the MTA where we kind of walked through different components in the model, and all sorts of questions on configuration and the alignment would come up that I don't remember really catching before when we would just send static screenshots. And again, the same method can be used for public-facing stakeholders, members of the public, and advocacy organizations, and so on. In the past, we never, even if we had animations up on a screen in a physical conference room, there still is, I guess, the value for members of the public in having the modeler be present and live drive into the model. The impression that a member of the public may get that we're responding to a precise bit of feedback or to a precise question they have is, oh, can you go over to my building for a second? Or I have a business in that building right there. I want to see what something looks like from this perspective. That's something that those comments we can address on the fly And that the appreciation that that member of the public can get when they see their comments being addressed live is something that's a little hard to address if you have like a pre-recorded animation or images where someone can be standing by the animation, but if it's pre-recorded, they obviously can't address any concerns that haven't been thought of in advance. It's just a close-up zoom in of that same screen recording we did for an IBX outreach meeting where we shared a conventional rail configuration in the cuts. I think this is at close to or around Ocean Avenue in Brooklyn. In this, we got various comments on zooming into various details depending on different stakeholders' interests. I think I saw a question from Mark. Go ahead and jump in. I can continue.
We're just not able to see the shared screen. There must be a problem from our end.
Oh, gotcha. Are other people able to see it? Gotcha. Okay, cool. We got others. Yeah, sorry about that. That is one of the things I wanted to address on the downside slide. We'll get to that in a bit in the presentation. Is pretty much technical issues always emerge in screen sharing. That's something, if you have a physical board or image printed on a physical board, as long as it doesn't get ruined in the rain or something like that, it's definitely there. So technical issues continue to be a perennial issue with sharing animations and things virtually. Yeah, so just a recap of the benefits compared to the typical approach of sharing static materials. Lots of boards with complex arrays of images, diagrams, and plans can accomplish somewhat, but a 3D model just, there's a reason those cliches linger, like a picture is worth 1,000 words. So a model may be worth 1,000 pictures, is what I think. And you may even require less staff to stand by boards if you simply have the model creator standing by the virtual screen share to share different components compared to multiple staff standing by multiple boards. And just the comprehension of the 3D model seems more interactive than a bunch of static materials. And of course, many may remember that's exactly why a lot of infrastructure projects and architecture projects, I don't see it too much anymore, but in the past, they would actually build 3D miniature models, and reviving that practice via virtual 3D models is exactly, it brings forth the benefits of physical models that used to be used in the past. Of course, physical models are more expensive. They tend to be built towards later phases of a project. At those points, usually feedback can no longer be provided, or it can't be integrated as thoroughly as massing models that can be brought earlier into the project concept development phases. And of course, there are limitations and challenges, one of which we just experienced. If you do make use of animations, unlike live driving of a 3D model, that obviously takes time and skill. So not every company always has the staff available, or there may be limited staff, and they're always booked up with multiple projects, so they may not be able to do things unless they're very well done in advance. Whereas some careful model driving and even some simple generation of matching images and layering them in PowerPoint, it can be a very versatile workaround. If the 3D model has to be shared after the live meeting, that can still be difficult due to file size. I've actually shared 3D models via PDF. You can actually embed 3D models via PDF, and you can embed them in PowerPoints as well. The value of this really drops off once the model starts getting really complex. So, really large street scenes like this with many details and lots of streetscapes. Their file sizes are so huge that once they go into PowerPoint and PDF, the models just become so slow to move and pan around, and the file size becomes so large that it almost isn't worth it sometimes. Whereas, if you have like a single, machining component, or a single, let's say like just a single bus stop or a single car that you have to show, that's something simple like that is much easier to embed in a PowerPoint or a PDF. And of course, it's still, because we have to serve a wide variety of demographic groups with different access to technology, it's still, I can't emphasize this enough, it's still valuable to include print outreach materials. And of course, those still rely on static imagery. So yeah, just wanted to thank everyone and open it up to questions. If you do have I can answer some questions on the IBX, but if you have really detailed technical questions about the IBX, those are probably better directed to MTA directly, or you can direct them to my ACOM project manager, Renee, at the email address below. And I also just wanted to plug the web address for the IBX. There's a dedicated project website, which includes a really cool video that the MTA visualization team put together, where they took our 3D models and took them even further. So they do have the resources, amazingly, which a lot of transit agencies don't necessarily have, of a dedicated animation department and animated fly-throughs and walkthroughs through some of our models as well. Yeah, are there any questions? Nice. I'm glad addressed everything. So hopefully there's no confusion in any of the slides I had. So with that, I'll toss it back over to Vinay.
All right, thank you so much, Marc. And up next will be our two presenters from VHB, and I will let Alvaro introduce his colleagues.
Sounds good. Thank you, Vinay, and thank you, Marc. All right, so we'll transition quickly here to our next presentation. So we've got two presenters for this one here, and it's titled Finding Relevance in this, sorry, one second here. Finding Relevance in a Sea of Data for a Network Redesign, Supporting Right-On Reimagined, and we presented by Darrell Smith and Peter Fortunato. So I'll introduce Darrell first. Darrell Smith is the Director of Transit and Rail Planning for VHB's Metro's DC office. Darrell has extensive experience in balancing customer and community needs with practical operating practices to develop transit planning solutions. He brings a unique perspective of developing and implementing new services and passenger technologies. Darrell spent most of his over 30-year career at passenger transportation operating organizations split between bus, rail, and paratransit. This included the Jacksonville Transportation Authority and Amtrak, as well as running his own business providing intercity airport shuttle service and public transportation consulting in Florida. His experience gives him a detailed understanding of transit system delivery to provide implementable service plans and schedules. He also leverages his experience to help customize tools to assist transit operations and ridership. And Peter Fortunato is an interdisciplinary transportation data scientist on the Transit and Rail Planning team of VHB Metro DC. As an advanced user of the R programming language, Peter assists his colleagues across multiple teams at VHB with writing scripts to process data, development and maintenance of web applications, and visualizing and communicating actionable insights from data. Previously, Peter primarily focused on modeling and evaluating highway safety performance for the Metropolitan Planning Organization, covering 8 counties in 3 states surrounding greater Cincinnati, Ohio. Peter's guiding azimuth is to help design a safer and more equitable transportation system that provides the means for anyone of any background to get to where they need to be. Without further ado, go ahead, Peter and Darrell.
Okay, thanks, Alvaro. So we're really thrilled to be with you today and share a little bit about what we're working on as part of our Ride-On Reimagined comprehensive bus network study from Montgomery County. Just to share with you real quick that, I entered my career actually at Amtrak and got used to having all of this detailed data since, we collected tickets from everybody and we knew where everyone got on and got off and what train they were on and, even, what class of service they used. And then I went to the Jacksonville Transportation Authority and my new boss came in and he said, so, I'd really we need to turn our ridership situation around and really looking forward to you being able to add something to it. And I looked at him and I said, how on earth do you expect me to be able to say where the bus should run when you can't tell me where people get on and off the bus? It seemed to be kind of a basic thing. And he said, oh, well, we've got 5 of these things you might be interested in. They're called automatic passenger counters. I'm going to give that project to you and you can run with it. So you can kind of get a sense of this was the very beginning of big data in transit. And I'm so excited now that in my career, I have someone like Peter working with me as a data scientist and that we've evolved to that level. And it's just been really fun having Peter on board and really excited to be able to present to you together today. Next slide. So first, just real quick on what is Ride On Reimagined. So we're taking an in-depth look at Montgomery County's entire bus transit system. So it's both Ride On and Metro Bus. And yes, Metro has their own Better Bus Network study underway. So we're collaborating with them and doing a lot of coordination with the county on that. And at the end of this thing, it's a little bit different approach. It will include a service implementation plan that gives phases of service enhancements and changes that essentially correspond as different bus rapid transit corridors come online or as resources are available. So whereas Metro is moving on a much shorter term time frame, the ride-on approach is phased, and some things may happen right away and some things may happen over a decade from now. In the end, it's a very comprehensive study looking at other things such as the brand, how to retain bus operators or attract new bus operators. So it's very broad based, and the county is really looking at it as a tool to advance its priorities on improving racial equity and mitigating climate change. And so that means a lot of collaboration with their zero emissions bus team, for instance, as they aim to get out of the diesel era. Next slide. So I just thought I'd share with you real quick some of the goals. The county has 3 overall focus areas. Oh, disappeared. So there's safety and vision zero, and that includes both bus and bus operation safety as well as the wider, I want to say pedestrian safety mix, because anyone that rides a bus is also a pedestrian. And the third one.
Slides disappear on you?
Yes, they did.
Sorry about that. Let's see here. The slideshow is still going. 1 second. I apologize for technical difficulties.
And just let me know in case you need me to open it on my end as a backup. But I think we're good.
I can do.
It should
Oh,
be
there we
good.
go. Okay, great. Okay, so then we've got, oops, and so we go back over there. We have environment and climate resiliency. So there's a number of these which are really focused on, modes should split and getting more people on transit. But also, one of my favorite is promoting the ongoing evaluation of the network. So as I like to say, if you do a big network redesign, if you have to do another one in 10 years, you didn't do it right. The system really should have a tool in order to constantly evolve. I like to always point out, when was the last time you heard of an airline doing a network redesign? They don't do that because they're always making changes. They're staying changing with conditions for the market and with operating conditions. And then the third area is economic development and equitable access. Yes, it's really true. I could not say that when we first started this project, but a year into it, I've got it down. And this one really focuses a lot on the imbalance between where the job growth is and where the low income and persons of color, persons of low income are residing in the county, and there's quite a mismatch there. And then the last one there is improving the passenger experience, which, it basically comes down to, you really want people to want to take the bus, not feel like they have to take the bus. Next slide. Okay, so it's a pretty comprehensive study, as I hope I expressed that to you. Bottom line is that there is now a lot of great data out there when you come to transit. So Montgomery County itself has automatic passenger counters on every bus. What that means is it's an automatic vehicle location GPS based system that every time the door opens, and you can see the little readers, it counts how many people get on, and in the back door how many get off, as well as the front door how many get off. It's tied to a record of the lat long for the location, as well as a timestamp, so you can associate it with a trip and with a specific stop. So it's really great data. WMATA has gone a step further with its trace data. So it has actually taken that passenger counter data and related it back to its transfers using the smart trip data. So really a very sophisticated data set that we have also had access to in this study. In addition, we have paratransit service with Metro Access with individual pickups and drop-offs, so we were able to get that data. In addition to all of sort of the usual stuff, right? What's happening in terms of the overall transportation plan, what U.S. Census and through American Community Survey shows us. There's just a ton of other data out there, and trying to figure out a way to bring that together. So the map that you see on your screen there is highlighting that APC data where people get on and off the bus. The bigger the yellow diamond, the more people got on at that location, and the bigger the blue square, the more people got off at that location. And then the blue shading is some extra work we did to say, where is there not much or any bus service, but a high propensity of likelihood of people to want to use the bus. Next slide. So you kind of get a sense of this, that, that, as I mentioned, it's a comprehensive network study. The county is 500 square miles. There's somewhere around 80 ride-on bus routes and 20 metro bus routes. So we're dealing with over 100 routes across the county. It's a very large network. And we thought, how on earth are we going to express all this data? Because it's a network study. We're not doing what's called a comprehensive operations analysis, where we're just looking at individual routes. We're looking at how should people be moving across the county, and make some sense of that. So we look at the usual things like census tracts and zip codes. And the problem with those, as some of you may know, is that they vary in geographic size. So visually, they're kind of hard to really process in your head, because if you start looking at population density and things like that, it's a little confusing or misleading when you start looking at it in terms of different sized areas. So what we came up with was an approach where we used R to calculate standard sized hexagons. And so we applied to that across the county map, and you kind of see that here where we're showing you the transit mode split. So in the red, you can see where it's highest using transit, and then in the blue shade there is where it's lowest. But you can see it gives you kind of a heat map sense, but keeps everything on equal footing across the county. Next slide, Peter. So these were really small enough. These were about 1.5 miles for each hexagon across, but you can kind of see it gives you a sense of, in this case, we're looking at the average weekday boardings and alightings across ride-on and Metrobus. So we aggregated the data that was at the stop level into these hexagons, so you can kind of see the hot spots that show up there. Many of those are fortunately centered around transit hubs where there's multiple routes connecting. But you can also see it's a fairly tight area around the county and it kind of indicates obviously where the service is, but gives you a better sense of where things are flowing. And you kind of see leaping out at you that I-270 Maryland 355 corridor running up the sort of the up county, down county, towards the northwest spine of the development. And so, yeah, let's go to the next slide, and you can see how these hexagons really do sort of give you a sense of easily comparing different data sets. Now, we do also have this available on the Ride on Reimagine website, which I'll give you. You can link through to it, as this is a dynamic mapping feature. So for those that are really excited about this and want to explore it, you can go and check out the layers on their own. So in this case, this is kind of a easy show of how this data compares. On the left, you see where the paratransit average pickups are from 21. Whereas in the slide, in the screen on the right, you see a snapshot of the population concentrations of individuals with disabilities. So not too surprising that where there's more paratransit pickups on Metro Access, it sort of correlates over with where those populations are concentrated. Next slide. So, as we went along, we had our usual data, but the county wanted to go further and really, not just look at traditional transit data sources, but also, okay, what is overall mobility? How, knowing that transit is a relatively small share of total travel across the county, what's another tool? So we ended up using StreetLight data. This is mobile phone based data to try to better understand what those trip patterns are. But the challenge is that StreetLight data, it's privately sourced, and so it's priced on the number of zones used. So using our hexagon approach was just plain cost prohibitive. It was gonna just way more budget than the county had available in order to do that. So we had to start from scratch and think a little bit differently. And we ended up using a drill down approach. We started with some larger zones. We actually had 5 focus areas, which we have had a series of focus groups. We started with those, and then we broke down and basically used something along the lines of traffic analysis zones. We had a budget for able to use up to 250 zones, and so that's what we worked with. And I'm going to turn it over to Peter, and he's going to kind of walk through how we actually pulled this data and used it in a sensible way, and then I'll be back to tell you an application of it.
Thanks, Darrell. So how does StreetLight work? So StreetLight is a startup out of San Francisco that offers users the access to mobility data sets, which are massively big data sets, mostly consisting of GPS pings emitted from mobile devices and sometimes automated passenger count devices that we talked about earlier. In the last decade or so, there have been an increasing number of OEMs producing so-called connected vehicles that emit not just GPS data, but also much more information about the operation of the vehicle, such as hard stops and hard accelerations. However, this data, as you can imagine, is a lot less prevalent and a lot more expensive. However, regardless, all of this data is considered big data, which is data that can be defined by the 3 V's of volume, velocity, and variety. In order for the platform to work, StreetLight has to develop their own machine learning models that serve to aggregate billions of these GPS pings into unique trips that can also be attached to an existing roadway network with all its quirks and inconsistencies. So what do we get from StreetLight? What happens with the output from those machine learning models is that we get several different kinds of analytics products that help us transportation planners do our job, such as origin destination travel patterns between pre or custom designed zones. These metrics are then presented in a data visualization dashboard. So for our analysis, we conducted, for our mobility analysis of Montgomery County, Maryland for Ride-On, we used samples collected by StreetLight during the months of March, April, September, and October of 2019. And as Darrell mentioned earlier, we had created different geographic zones within Montgomery County. We have 36 regional areas, which are cover all of Montgomery County, as well as areas that are immediately adjacent to Montgomery County in both Maryland, the District of Columbia, and Virginia. We also have 55 smaller activity areas, which are composed of neighborhoods entirely within Montgomery County. So activity areas are all within Montgomery County, whereas regional areas include areas outside. So when looking at the values that, one thing I would like to note is that when StreetLight gives you its data, and when we're talking about trips between origins and destinations, StreetLight is really clear in this distinction between volumes and indices. So StreetLight's volume represents an estimated trip counts as calculated by their machine learning models, whereas index values represent relative trip activity. So just a heads up, you can't exactly compare volumes and indices straight up, but they still give you a good indication of what kind of travel is happening. But anyway, you get a lot of analytics from StreetLight that help us do our job. And as I mentioned, StreetLight gives you your query analytics via data visualization dashboard that looks something like this. You can see the regional areas of Montgomery County and the surrounding areas on your map. So the problem with this output is that the dashboard is not suitable for presentation to neither Montgomery County DOT nor the county's million-plus residents. And Darrell has a wealth of experience communicating this type of information to the general public and knows what kinds of visualizations work versus those that are confusing.
And this was a challenge because, as you can imagine, what we really wanted to express is travel volumes between origin and destination zones. So when you see an image like this, you can just start to think, how on earth would you show that? A bunch of arrows, change the width of the arrows, and then you start thinking about the number of zones. That might work if you have 4 or 5 zones, but when you start talking about the 55 plus just within the county that we worked with, it would be absolutely nonsensical. So that was the challenge.
Right. And another problem that I, as a data scientist, have with this presentation is that it's not reproducible. You have to point and click your way through this dashboard to extract the relevant insights, and relying on or relaying point and click instructions to someone else leaves a ton of room for this kind of critical information about the data or the platform to fall through the cracks, and then you're putting your whole analysis in jeopardy. So we knew on multiple fronts that this wasn't going to cut it for what we needed. So our solution was to figure out, we have all these other tools available to us to make StreetLight work for VHB and Ride-On. So how I approach this problem is that I want to take that raw data that is output, that is powering StreetLight's own dashboard, and use this data to produce our own in-house platform. So as a data scientist concerned with reproducibility, my go-to toolkit is the open source statistical programming language R, and a suite of additional open source tools and package libraries that provide me with everything I need to slice through this data. So just quickly going over this, R is the programming language that I write. R Studio is the environment in which that I write my code. The tidyverse and those hexagons that are around the tidyverse are a bunch of additional packages that kind of all follow the same data science philosophy that really help me bring together a whole bunch of different functions together to make a really nice and seamless data analysis. Shiny is what enables us to build these web applications that we can share, like the previous application that Darrell showed before. That was also made with Shiny. So was this StreetLight web app that we created. And then Plotly adds some additional interactivity to the visualizations that we make, which will become more apparent in a second. So our solutions with using open source tools and the raw data that StreetLight gave us was to, as I said earlier, build an interactive web application that visualizes origin destination patterns, as well as writing a memoranda as analytics notebooks that can interweave code, text, and images into a singular document. So let me just touch on analytics notebooks real quick, because I find this to be a really exciting tool to use in the future. So this is a screenshot of RStudio. This is what I open up every single day to do my analysis. And what I'm showing you is a screenshot of a file in which on the left, you can see the raw, quote unquote, script that I'm writing, but on the right is an output of that script into a nicely formatted markdown file, which can be thought of as like any web page that you can put onto the internet. So what's really cool about this technology is that you can as I said, you can interweave code and text together, which, in keeping with the theme of reproducibility, this enables me as a data scientist to write the code that I use for my data analysis and write the actual prose and presentation material all within the same environment, so that I don't have to go in between RStudio and Word or ArcGIS Pro or something. No, it's all within here, and I can, the seamless environment between starting your analysis and producing a PDF file that we can send, or an HTML file that we can send to our clients, is something that I personally find really exciting. But anyway, back to the actual the app that we really were that really helped us was this origin destination StreetLight Flows Explorer. So I'm going to show you a couple of screenshots from the app that we developed. So rather than showing the zones with a choropleth map like you saw earlier, we were more concerned with looking at the origin destination pairs rather than the individual zones themselves. So given this, I realized that a tile matrix, like the one you see on your screen, would be the most concise way to display this data so that the most traveled pairs become immediately obvious. And when you're dealing with, say, this is the regional area, so 36 areas, and the activity areas, which are 55, 36 by 36 and 55 by 55 get really unwieldy. But if you just concise this down into an OD matrix like here, and then you add some interactivity to it, where obviously this is a screenshot, so I can't hover over it, but when you open up this app, you would just hover your cursor over each of these squares, and it just shows you origin, destination, and the count. So this was really helpful in just saying, okay, we got all this data. Where is everybody going? I just found this layout much more straightforward, and it's obvious what data you're looking at, as well as how to change the data that you want to see. When I look at StreetLight's dashboard, I'm just afraid that like one wrong click will mess everything up and the dashboard becomes like uncalibrated or something to that effect, and it's just adding on more stress. So again, these I'm going to show the different toggles that you can make to get the different areas, the different vehicle modes, the different day parts, and the different day types. And it's all reactive, and it really just shows you exactly what you need without really making you dig too deep. So, oh, excuse me. So the final screenshot that I want to share, again, our goal was to understand origin destination travel patterns in order to make a recommendation to Ride On as to how their network should be reimagined. So not only did we need the matrix to show us what stands out, but also we needed a ranked list of the 3 types of origin destination pairs. So just all pairs, the non-within pairs, the origin and destination are different, and within pairs where the origin and destination are the same. So by ranking each pair within these groups, a major insight reveals itself. So much of the travel demand that we're seeing is for short trips within zones. So as you can see here, the top 16 OD pairs for all vehicles in the activity areas for the peak PM day part Mondays through Thursdays are all within pairs. So with solid evidence for this phenomenon repeating for so many other day part, day type combinations for both activity areas and regional areas, we were able to make a confident recommendation to Ride On as to what they should do as part of their network reimagination. So one more thing before I hand things off back to Darrell. Because we emphasize reproducibility throughout this entire analysis, this process is packaged and ready to go for any other geography. If, say, we're asked to do this kind of analysis for Forsyth County, North Carolina, or New Haven County, Connecticut, all we need to do is just query the same kind of data from StreetLight and run these CSVs through our code. And maybe with some minor tweaks, we would have the same exact app for the different geography. So if anything, reproducibility helps you, excuse me. If anything, reproducibility reduces the time spent on processing the data, increases the amount of time that you have for your analysis and presentation.
All right, so thanks, Peter. So as Mark said, you can always count on the technology to fail, and of course, Peter's machine wants to reboot because we're doing a presentation. What you might have noticed in the graphic that Peter shared is that you know first you see that straight line that went up the middle of all the darker blue, which was just indicating, hey, this is the strongest amount of travel was internal to the zones, and so that's why working with Peter, we said, okay, we better actually look at the actual counts, and yeah, those are trip counts that are coming out. I think that was one of the questions I saw that are coming out of it. So we're looking at these volumes and going, we've got to do something a little bit different. And, circulating around an individual area is challenging for transit. We actually just had a stakeholder meeting this morning and someone asked, hey, was there consideration of running circular routes? And I don't know if anyone's ever used a circular route, but it basically takes you a long time to get anywhere because your round trip means you're literally making a round trip going around a circle. So the county has been experimenting with, sort of what I call the trend in transit, certainly out of the pandemic, has been moving to micro transit, or what they call in Montgomery County flex, which is a service type where essentially you reserve a vehicle is assigned to a specific zone. The zones are typically 5 to 7 square miles. Some places do them a little smaller, some of them do a little larger, but generally somewhere between 5 and 7 square miles. And the vehicle circulates, and you have a smartphone app and can basically reserve your trip and say, hey, I want a vehicle, just like you would with Uber or Lyft. The vehicle comes, takes you to the nearest spot it can let you off for where you requested. In Montgomery County today, there's the 2 zones in Rockville and Wheaton. We've actually are looking at expanding that dramatically across the county to a number of different zones and 2 different types. One, which is sort of the diagram, the upper diagram is as I described, a vehicle or multiple vehicles, depending on demand, circulating within this defined zone. The other, in more rural areas, the challenge we found with these is that it isn't just about local circulation, but it's also connecting to the overall fixed route transit grid. So, the regular buses and the new bus rapid transit and Metro Rail. So some of the areas are pretty far out. So what we did for a couple of them, our proposal is emerging to be where there is a specific zone where the vehicle will circulate, but then it transitions to a regular bus type service that runs on a regular schedule to connect to a major transit hub. So that, for a portion of the service, the route acts like a regular bus. And then for the other portion of the service, it acts as micro transit, say for the last 30 minutes of the trip. So it's kind of an interesting thing, very intriguing for the rural parts of the county, but definitely directly comes back to the data as Peter presented of the highest volumes are not from one area to another, but within the area itself. And with that, give you here, that's the county's website. So if you go through, you'll have to go through a couple links, but you can, in the report section, find the interactive tool with the data. And it looks like we've got some questions. So thank you very much.
Awesome. Yeah, thank you, Darrell. Thank you, Peter, for this presentation. And yeah, looks like we got 4 questions in the chat, so I'll just read them and then let you answer from there. So Jim asked, is Quarto what binds it all together in a production output? And are these all person trips?
So I can answer the Quarto part. Quarto is another open source tool that is at our disposal for producing interactive web documents, or think of like PDFs, or that you can post on a website that they're interactive and you can scroll through. The idea with this is that we would want to move into this direction of when we have memos that require data analysis, some like output from a process like a table or a plot or a map. The idea of reducing the space between the analysis and the presentation is what enables Quarto to do that. But Quarto was not involved in producing the app, if that answers your question.
All right, and then the question about person trips. So it is vehicle trips for the auto data, and as Peter mentioned, there's a few different data sets in StreetLight. So there is separate transit trip tables, and then as well as the auto tables. And the auto tables, which is most of the data we were presenting, are actual vehicle trips. So they aren't actually person trips.
Jim has one more question here. He said, I did not realize that StreetLight provides expanded auto person trips. What I have seen is that they expand their indexes to auto trips and not person trips. How did you get person trips made in autos? Unless you already answered that.
Right, and that's and that's exactly what I'm saying. It is auto trips, not person trips.
Okay. Awesome. And then the last question we have here in the chat is from Benai. Was there any consideration / analysis to compare OD pairs with MWCOG equity emphasis areas?
Yes, we have actually been analyzing the equity emphasis areas, and that is part of one of our study goals is improving equity access across the system. We are, as we one of the things that you will see, and we'll be going out more to the public in September with the actual concepts. But one of the things we're really looking at is how to really improve the east-west connections across the county. If you're familiar with Montgomery County, there's some of the equity emphasis areas are rather interesting, but they're many concentrated down county and on the eastern part of the county, but there are some further up county centered around Germantown and Gaithersburg. But getting folks from the eastern side of the county to the western side of the county, the transit network really evolved as along the corridors radiating in and out of DC. And as employment has grown, that employment unfortunately has been growing more up county to the north and west. And so getting folks there, a lot of the feedback we've even gotten has been, it takes 2 hours or more, and that's just too long, and I don't go. So it really has been, if you don't think of it driving, because even on a bad day on 270, you get there within an hour. For a transit trip, it's pretty long and arduous. So good question.
So those are all the questions from the chat. If anyone has any other questions, feel free to unmute. Okay. Yeah, hearing none. I think we're good there. But yeah, just want to thank all our presenters today, Marc, Darrell, and Peter. Just a quick wrap up here. This meeting is being recorded, so we'll have these presentations available for you all to look again in the future. We have a YouTube page that we will be posting this on, and we'll pass that link along in the future as well once we get that posted on our YouTube page. And then lastly, this meeting was also approved for 1 PDH credit. So we'll also be sending those instructions to reclaim that PDHs to all of the registered attendees. But with that, yeah, thank you again for everyone for attending this. I'll give you 10 minutes back for your lunch. And yeah, hope you guys have a good rest of your day.